Hello everyone, welcome back to the channel. In today's video, I'm going to show you how to set up and use the Raspberry Pi Pico in VS Code. Let's get started. First, open VS Code and go to the extension tab. Search for Raspberry Pi and open the official extension provided by Raspberry Pi. Click install, then select Trust Publisher and continue with the installation. It may take a couple of minutes, so I will be fast forwarding this part. This page contains the basic information about the extension. Once the extension is installed, you will see a new Raspberry Pi Pico icon in the sidebar. Click on it to open the extension panel. When you open the extension, you will see several quick access options on the left side, such as compile, run, flash, and many more. I'm going to create a new project from an example, which I also recommend for beginners. Next, select the example you want to start with, choose your board type, and pick up a location to save the project. There are some advanced options you can explore. I will enable CMake since I will be using it. Now click on create to set up an example. The extension will then install the required SDK based on the Raspberry Pi Pico version you selected. And again, this will take a couple of seconds. Now I'm going to install the basic dependencies. Most Ubuntu version already include those by default, but just to be safe and so we don't miss anything, I will list and install them here. Now that we have our Pico SDK set up and ready in VS Code, let's walk through a simple example to verify everything works correctly. This code is basic LED blink example, but with a twist. It works with both original Raspberry Pi Pico and Pico W. Let's break it down. We will quickly walk through it. At the top, we include Pico stdlib header. This gives us access to essential SDK functions like GPIO control and timing. Next, we define macro called LED delay ms, which controls how fast LED blinks. Then we have function that sets up LED depending on which board we are using. If Pico default LED pin is defined, which is the case for regular Pico board, we initialize the GPIO pin and set it to output mode. Next is the Pico set LED function. This function turns the LED on or off. Again, the logic is split based on the board. Now we reach the main function, which is the enter point. Here we call Pico LED init function to initialize the LED. Then we enter an infinite loop. In this loop, we are turning on the LED and after some delay, we are turning off the LED. Again, wait for the delay. This gives us a steady blinking pattern. Once the Raspberry Pi Pico extension is installed, you will notice some new buttons in the bottom right status bar. Click Compile button to build your project and generate output files. You can also click the Pico icon in the sidebar to access quick actions like compile, run, flash. Likewise, we have many more options. To upload code, hold this boot select button while plugging in your Pico board to enter into USB mode. If you are on Windows, then just hit run, then your code will be flashed on your board. But in case of Ubuntu or in case of Linux, it doesn't work straightforward. It doesn't work in one go. When I tried running it, I got this error in the terminal. This means that system can see the Pico but cannot write to it. Now there are a couple of ways to fix this. For example, adding udev rules or using sudo with Pico tool. But if you want quick workaround, you can simply copy the generated .uf2 file manually. Just open the Pico's USB drive in your file manager and copy paste the .uf2 file into it. The board will reboot and your program will start running just like that. Or if you prefer, you can copy the binary file to the Pico using command line. That's it for today. Thanks for watching. If you found this helpful, don't forget to like, share and subscribe.